Dr. Barari is a quantitative social scientist at NORC at the University of Chicago, working on applied problems at the intersection of survey methodology and data science. He's an adjunct assistant professor of political science at Columbia University and trained as a political scientist with substantive expertise in media, political communication, public opinion, and elections. He holds a PhD in political science and an AM in statistics from Harvard and a BS in computer science and mathematics from Tufts. Previously, he worked in research and data science roles at SurveyMonkey and Microsoft Research. He writes about politics, data, and social science for a Substack newsletter called Somewhat Unlikely. If you could keep yourself muted, and if you have questions, put them in the chat, or at least substantive questions. If you have sort of clarifying questions as the talk goes, feel free to raise your hand or put those in the chat as well. So let's welcome Dr. Soubhik Barari.
Thank you. Well, thank you so much, Clint, for that generous intro, and thank you, NYU PRIISM, for having me, and folks for tuning in on Zoom here. I'm going to talk to you about the intersection of a couple of things today. So the intersection, as you can tell from the title, about AI and survey methods, and maybe some other things as well. Clint already introduced myself, so I won't go on more about my own background. Just a little bit about NORC. So NORC is a social science research organization. We work with everyone from the CNN to the CDC on social science research, spanning a wide range of areas, not least of which is survey research. So just to set some context here, and I also want to, before we get into things, I want to acknowledge the team that worked on what you're about to hear, which includes a range of folks who specifically work in the methodology and quantitative social science department at NORC. Okay, so I want to motivate this talk in terms of a very, very core problem in the field of survey methodology, and by affiliation, all other fields in social science or computational social science that use surveys, which is that there are two traditionally separate methods of survey interviewing. You might call them standardized interviewing and conversational interviewing, although the second goes by other terms as well, such as flexible interviewing. And the way to think about these two is, the analogy here is that standardized interviews are crafted, in sort of an assembly line fashion, right? Whereas conversational interviews, it's a sort of bespoke product that's created and crafted, by, like a craftsman in a woodworking workshop, right? So that's kind of the analogy of these two different modes of survey interviewing. So let's talk about what that actually means. So standardized interviews are what you all, if you've worked on surveys at all, or even taken surveys, are probably most familiar with, right? So let's talk about what standardized interviews are and what they offer us in terms of data collection. So the pros are that they're efficient, right? The web survey is probably the pinnacle of this innovation. Very easy to automate, very easy to scale up to 100, respondents, 10,000 respondents, 100,000 respondents. It is both consistent and comparable. It's consistent because you're asking the same questions to everybody, and the responses are comparable because they're in a standardized response format, right? Everyone is answering the same question, and everyone's answering in the same way to every single question in your survey. But let's talk about the weaknesses of this approach, right? So the weakness is that it's an inflexible means of data collection. Neither you nor me, if I'm the researcher, can ask clarifying questions. You can't ask clarifying questions about what my question means. I can't ask clarifying questions about what the heck it is that you said to my, responded to my question. Seemingly simple questions like, are you looking for work this week? Something that's asked by the Bureau of Labor Statistics can have many different interpretations depending on who you're talking to, right? And there's not an opportunity to have clarifications in the standardized interview format, right? Similarly, there's not really an opportunity to collect more depth at the individual level, right? So I can't ask you a follow-up question based on what you said to my original question about, are you looking for work, or what kinds of work are you looking for, right? And this might be insightful for some kinds of topics to get, information on things like motivations or reasons or contextual information that might be helpful for, the research question that you're trying to answer, right? And finally, it's very hard to personalize these kinds of questions in these kinds of interviews. Of course, if you work with web surveys, you know that you can pipe in, let's say, demographic information that you get about a respondent at the very beginning of your survey into subsequent questions, and it creates the appearance of personalization. But of course, A, that's burdensome, and B, there's a lot of open-ended information that you might be collecting from your respondent that might be useful, and it's very, very hard to incorporate that into later questions, right? So we got some pros, we got some cons with the standardized interview format. Let's talk about conversational interviewing, right? The kind of bespoke craftsman's interview. The pros here are exactly in some ways the cons of the standardized format, right? So the opportunity to have a conversation it creates a bi-directional experience where both me and you can actually ask clarifying questions. I can clarify to you what I mean by work. You can clarify to me what you mean by, being a content creator or something, right? You can similarly elicit depth, right? I can ask follow-up questions, maybe even follow-up questions that allow me to clarify what you meant by your original response, right? And finally, you can personalize the questions that you ask based on the exact responses or the experiences that the respondent is talking about. Think about the use case of reporting something very personal, like reporting a hate crime incident, right? This might be intensely personal for an individual, and you want to ask questions that are that account for that personalization, account for the specificity of their experience. Another example might be asking questions about somebody's recent, medical appointment or experience at the doctor's office, right? These are all very, very personal, vary tremendously across respondents, and you want to get personal in the questions that you ask about it. Of course, there are lots of cons, and maybe this is partly why you don't see a lot of these surveys, at least you haven't seen a lot of these surveys traditionally in the last 20, 30, 40 years of survey interviewing, certainly on a mass scale, right? Incomparability, right? There's the risk of what we might call construct drift from a psychometric perspective. Because you're asking different questions, different people might actually have the opposite, where they're actually interpreting the question differently because of changes in the wording. And also because you're asking typically for open-ended responses, this creates the problem of incomparability. There's an additional step you have to do in order to compare responses in a quantitative way between respondents. Of course, this is also inefficient. Human interviewers are expensive, and there's the risk of inconsistency, right? Human interviewers are human, and they might ask questions in a different way unintentionally, right? And those are all bad. So that being said, wouldn't it be great if there was some technology that could bridge these two, worlds of survey research and bring out the best in both? And that gets us to, and I'll just mention there are a couple of excellent citations, describing each of these facets of these two modes here, which I'd encourage you to look at. But so enter generative AI, right? So generative AI, I'm quite sure that many of you, if not most of you, are familiar or have a working definition of it, perhaps have used it, perhaps even used it in your own research. But I really like to cite Chris Bale's recent PNAS piece, specifically on generative AI as it relates to social science research. And so he offers a useful working definition, one that I'm sure is shared by most folks, certainly here, if not in the field. Generative AI is a shift from traditional machine learning methods towards the actual generation of text, images, and video. And why is this important for social science research? Well, one is that this capability has increasingly gotten to the point where it can impersonate human generation of those same media. And he even says that, and others have said, during the early days of this, that generative AI in large language models in particular have tremendous capability for improving how we collect data, in particular, in-depth qualitative interviews or things like detailed life histories that might otherwise be mostly done by a human, right? Okay, so that sort of sets the scene. The fundamental question behind our work, having said all this, is can generative AI, and specifically large language models, do two things? One, can it help us collect better survey data? And this is mostly for the researchers. but also two, and not, not unrelated to one, create higher quality survey experiences for the respondents of our surveys. Okay, so let's dig into this a little bit more. So when I say collect better survey data, what do I specifically mean? Firstly, I mean, can generative AI actually elicit more informative open-ended responses? Can we get elaborations on responses in real time? Raise the ceiling, if you will, but also raise the floor. Can we actually reduce the rate of junk responses that we get from respondents? If somebody, gives a troll response to an open-ended question, can we use generative AI to actually get something better out of that person? So raise the floor of quality. And then finally, many researchers, when they work with open-ended responses, while they do care about the actual open-ended response, are typically working with things like topics or, labeled, structured, data from that open-ended response. And so another question we're asking here is, can we actually do that structuring, that, so for example, classification, in real time during the interview itself? And we'll talk about why that might be useful to do rather than waiting until the very end. And so, okay, so now let's talk about the experience side of things. So you might imagine that generative AI makes surveys easier to complete, right? So respondents might be more likely to stay in the survey if the questions are clearly tailored to them and they're personal and they're not about some generic, construct that that doesn't relate to their experience, doesn't relate to their particular personal experience of that topic or what is being asked, right? And overall, we might imagine that generative AI creates a better user experience, right? So they might experience, respondents might experience less frustration if they can ask clarifying questions and so on, right? Okay, so that's the motivation. Let me tell you about what specifically we did. So what we did in this work is that we ran a survey experiment with a conversational AI platform. There are increasingly many of these out there to test the effects of two things. So AI-based reprobes and real-time classification. And our primary outcomes are data quality and respondent experience, like I mentioned, right? And the particular platform we used is called Inca, offered by this organization, Next Intelligence. Okay, so three primary research questions. Can specifically elaboration reprobes elicit more informative responses? Can what we're calling relevance reprobes reduce junk responses? And can this sort of live classification pipeline, what we're calling confirmation reprobing, produce more accurate coding of responses, the things that you guys are all working with, after you conduct your survey, right? And then finally, one additional research question on the respondent experience, which is we want to understand how all of this impacts the respondent experience at the end of the day, right? Okay, so let me walk through this in a little bit more detail. So research question number one, can elaboration reprobes elicit higher quality responses? So what are elaboration reprobes? So it's helpful to think about what the status quo is in survey research. So let's say you're administering a text-based survey, right? And you want to ask about the most important problem facing the country today. Many of you probably get, or did at least a couple months ago, get a lot of text-based surveys like this. So typically, right, you ask the question, the respondent gives you a very, very terse answer, and you kind of have to shrug it off and move on to the next question, right? Where you really wanted to get some more information about why they think, in this case, inflation is the most important problem, what they exactly mean by inflation, right? It could mean a variety of different things. And so the treatment here, the introduction of elaboration probes, allows us to actually follow up based on that original response, right? So here's a real example. This elaboration probe is acknowledging that's an interesting answer, right? And asks the sort of like why question. Why do you think inflation is the most important problem? And you can see we get a slightly more potentially interesting response from this particular respondent, right? Okay, so research question two is about relevance reprobes, right? And specifically whether relevance reprobes can reduce junk responding. And so let's return to the status quo, and specifically for this this question, right? So the respondent could be, very unkind to us and just, keyboard mash and give us a very, not useful answer at all. And so what we could imagine doing is actually, like holding them to account, right? Saying, I didn't understand what you said. Can you actually, give us something, useful here, right? And obviously say it in a polite way. And so, you can imagine getting an actual answer from this respondent, right? Okay, and then finally, can the process of confirmation probing during live classification produce more accurate coding of responses? Okay, so right, so typically we take a response like this, and then afterwards, this is you all, you're at your computer and you're actually producing a label, right? A structured label for this response. Maybe you're using topic modeling, maybe you're using an army of RAs. And so, here, right, you classify this response as being about cost of living. You could imagine an alternative, which is you actually do this during the interview. So you say that I interpret, you have the generative AI say, I interpreted your answer as being about the initial classification of that cost of living, right? And then you actually get the confirmation from the respondent that that's correct. So why would you want to do that, right? So if you're human coding these responses after the fact, the one coder that you would actually really want to code the response would be the original respondent, right? To make sure that you're interpreting the response correctly. And this is exactly what that allows, right? The respondent can actually confirm that you're understanding their response correctly. Okay, so those are the research questions and kind of some examples and motivation, hopefully at a higher level. Let's get into the weeds of the research design here. So what we did is we actually did a number of different experiments, all embedded within a single survey, a number of experiments across a range of different topics here, ranging from the most important issue question I just showed you to questions about evaluating economic conditions, and then questions that were what you might call more to do with nominal lists, right? So not really opinion questions, but about selecting among a set of like static choices and more like factual elicitation questions, right? So what is like your main news source that you go to, and what is your main occupation, right? Slightly different from the first two. And then in between all this, we asked a series of demographic questions, and we asked some self-reported respondent experience questions, like how frustrated were you by this experience, excuse me, and a number of other questions that I'll show you shortly. Okay, so and we split our experiment into three treatment groups. So the control was the status quo question, if you will, what you would typically ask if you were going to ask about that topic, with no probing at all on the seed question. And then we had two treatment groups. The first treatment group, we had a textbot, what we're calling textbots, administer either elaboration or relevance probing, depending on the content of the response to the seed question, right? And then the second treatment group, the textbot was configured to only administer confirmation probing. Okay? In theory, you can imagine, unbundling treatment one into, elaboration probes only and relevance probes only. But as it turned out for this experiment, that was actually difficult to do, and that gets into maybe some limitations of working with either large language models or vendors, which we can talk about. And we based all of these questions on reference surveys, lest you think that we're just making up these questions. Okay, so for the most important issue question, this was open-ended throughout, and the thing that we're trying to classify, right, in treatment 2 is the political issue, and the political issues in particular we got from a code book from Gallup, from the the kind of famous Gallup tracking poll. For the economic conditions experiment, we actually asked two questions. One was basically a binary question that was thumbs up or thumbs down about the economy right now. And then we asked a follow-up question that was in the control group, what's the reason for your response? And in treatment 1, we actually asked this in an entirely open-ended way. And excuse me, if and the textbot could either ask a follow-up question if they felt there was not, they being the large language model, if they felt that there was not enough information in the first response, or they could just proceed to the next question. And For treatment 2, we actually did a confirmation probe on each of the 2 questions in this sequence here. Okay, so similar for the news question, the control group, as I said, typically you ask these as like a kind of a closed-end list question. So that's exactly what was the control group. In both the treatment groups, we asked this in an open-ended way. And the code book, if you will, for the news sources was from our very own Amerispeak profile survey. Standard set of demographic questions that we asked about: age, gender, education, employment, and the occupation experiment followed very closely from the news experiment, right? And then finally, respondent experience questions. So specifically, we asked about quality, perceptions of quality. How easy was it to take this survey? Generally, how generally were you satisfied? And how frustrated were you left with the experience? And as the footnote says here, it's worth noting that respondents were randomized into one of these 2 from the start. So it's not like they could possibly jump from one group to another between the experiments, which is important to note. Okay, so let's dig in a little bit into experiment 4 so you get a better sense of what this actually looks like. So the control question here was something like this. Maybe you had a visceral reaction seeing all those different response categories and the very loquacious labels here, right? This kind of question is sometimes difficult to answer, especially after a long battery of other questions in a survey, especially at the end of a survey, right? It's when a lot of us were programming this, like we had a hard time even classifying ourselves into one of these buckets. But of course, this is important, right? So from a research perspective, right, it's important for the Bureau of Labor Statistics to kind of standardize, statistics by these categories here. But from a respondent perspective, difficult and annoying, right? The treatment groups for this question looked like this. So both of these were open-ended. So same question, open-ended response. Based on the response that was given by the respondent in treatment 1, if the textbot LLM detected that the answer was both specific and relevant, we went to the next question. If it detected that it was not specific, it asked a question specifically that to be more specific. Try saying that 10 times fast. And if it detected that the answer was not relevant, it asked a different question, right? So I didn't understand what you said. Do you mind rewording what you just said? Different goals with each of these 2 follow-up questions. In treatment 2, again, open-ended question. If a category was detected by the LLM and the categories were from that BLS codebook that you saw in the first in the control group, the same closed-ended responses. If the category was detected, we confirmed that with the respondent. Is that correct? If a category was not detected, or if we got the category incorrect, if the LLM got the category incorrect, we directed the respondent to basically the closed-ended question. So yeah, we got it wrong, or there was not a category detected. We directed them basically to the control group question. Right? Please select from the closed-ended list what best describes your initial answer. Okay, some details about how we did this. So we fielded this survey on a non-probability web panel. We had a sample size of about 2,000 respondents, split evenly across these three groups. We fielded this last summer. And an important point to note here is that, as you all know, large language models, you can train them and you can further tune them to a particular problem. And of course, you can prompt them to, behave in a certain way. We actually did very, very little, if any, of that stuff for this experiment. Basically, we wanted to know off the shelf how well could the large language model do those things that we told you about, right? Okay, so just to give you an example of a preview of what we found as we were fielding this, right? So for the most important issue question, respondents would again say very, very terse, short, often one-word answers. And then after we probed them, we typically got more, you might call them more interesting answers, right? Things that were more personal in this case. In the first case, they described personal experiences that informed their answer. It informed why they said job losses and crime rate. And in the second case, right, so they gave a slightly more informative, perhaps more emotive answer that was, informative for us to know, why they were saying economy, right? So in short, we were seeing that post-probing answers were of higher quality, generally more detail and more specificity and more context. Okay, so to scale up that evaluation, what we did is we had a team of RAs actually, first of all, define what quality meant in a standardized way, and take that rubric of quality and then apply it to our responses, right? So the RAs came up with these particular criterion for quality, right? So relevance at a baseline, specificity, explanations if they were required, and then like some basic things like, was there a complete response? Was it even understandable? And was there redundancy in the answers? In addition to that, we also had the respondents for the open-ended questions, code them into the corresponding code books, right? So coding, for example, the jobs in the environment response here into one of the categories from that code book.
So I think you have some clarifying questions in the chat.
Oh, sure. This would be a good time to pause. So I see slide 24 is the number of time to interact with. Oh, I see. And this is a good question. So in each of these cases here, there's basically just at most one interaction with the large language model. Although you could imagine to really have it be, a fully conversational interview that we don't, set these constraints ahead of time, but we did set these constraints ahead of time.
So that's one interaction per question, or?
Yes.
Okay.
Yeah. Although I guess in theory for treatment 2, if our categorization was incorrect, there's technically 2 interactions when they're piped to the control group question here, right? So, but that's an important question and may have implications for the respondent experience, right? As we're going to talk about. Okay.
Before you keep going, I had a question on slide 12, but you don't need to go back to it. Does Inca prevent like autocorrection or autofill in responses?
Yeah, that's a good question. Yeah, so we were able to toggle that on and off. So we turned off autocorrect.
Cool.
Yeah. And importantly, while we're on the topic of Inca and the research design, and we can talk more about, IRB protocols and what you have to think about when you're administering these kinds of surveys. Everyone in this survey experiment, certainly in the 2 treatment groups, knew that they were going to possibly interact with a large language model. In theory, it is possible that a respondent may not interact at all with a large language model if they give the most beautiful, informative responses, and the large language model detects that they're specific and relevant every single time. But I think we found like 2 respondents in our survey who met that criterion. So take that for what you will. Okay, so some results. We won't go through all of them, but to give you the highlights here. So let's start with the confirmation probing. We found moderately strong off-the-shelf classification across our questions here. So for the BLS occupation question, 84.8% accuracy. This might be high or low depending on what your baseline expectations were, but we found that we were pleasantly surprised given no fine-tuning or prompting of the model. And not even, this is an example what you might call zero-shot learning, right? We didn't even provide the code book to the so we provided the code book, we provided the categories to the textbot, but we didn't actually elaborate any further on what they meant or give any examples. And so we found some evidence that there might be what you might call acquiescence bias in the confirmation part. So I'll tell you about that in a second. For the elaboration and relevance probing treatment group, we found actually mixed effects on response quality, meaning that some criterion of response quality, we found greater rates of that from the probing, and other aspects of response quality didn't improve. And there were really no effects on textual information. So we measured that a couple of different ways, and we didn't really find a lot of added content or added like lexical diversity or variety in responses. And we also found some negative effects on user experience. I might add some negative, but very small negative effects on user experience, which I'll tell you about. So specifically, maybe the most significant one is that we found higher attrition early in the survey in treatment group 1. So right after the most important issue question. And we found slight increases in self-reported frustration and satisfaction. So it's kind of a high level of what we found. So let's start with the classification accuracy. So this was the classification accuracy across the board. So in particular, the percentage of respondents who answered yes to the confirmation probe. Now that is actually different than what the truth might be, right? So we actually also had our RAs, if you recall, code what the correct what the correct category was across these questions, and we check for intercode reliability, and actually the accuracies were quite similar to what you're seeing here. And when, if you look at the confusion matrix for classification, you found that misclassifications were usually for closely related categories. So, cost of living and wages were often conflated for each other. And, some of this might say more about the code book being very granular and having a lot of, maybe syntactically similar categories. But we also found that errors were more often false positives than false negatives. And this is something I want to dig into a little bit here. So in particular, human coders actually coded none of the above more often than respondents actually confirmed that none of the above, that none of the categories were applicable to their response. So what does this mean? This means that respondents were saying yes way more often than actually those categories applied. And so basically respondents were kind of eager to say yes to the initial classification, which is an example of acquiescence bias, right? So respondents were biased towards a yes answer even if the classification didn't apply. That's what you're seeing here. The respondent rate of yes is higher than the respondent rate of none of the above saying no is actually much lower than the actual the coded rates of none of the above. In terms of response quality, we did find that, again, like I said, that some measures of response quality did increase. So specificity and explanatory details, we found a pretty sharp rate of increase. So the incidence rating, and I should say again, this is all measured using OLS that we've corrected for multiple hypothesis testing, and I'm showing you here both the baseline, the results without any sort of adjustment for covariates, and then adjustments for demographic controls, and the demographic controls that we pulled from the panel. So this basically avoids the issue of possible post-treatment bias. And so that being said, we can see, right, so rates of specificity and explanatory detail in both the most important issue experiment on the left of each panel and the economic conditions experiment, the middle of each panel, and also pooled together on the right of each panel did increase. Relevance, completeness, comprehensibility, and redundancy did not. And partly that is because the baselines for those were very, very high. There were actually not a lot of extremely irrelevant or incomplete responses to begin with in these questions. Okay. Like I said before, probing did not have much of an effect on measures of textual information. I think I may have skipped over a slide here. Yeah, so I skipped over a slide here. Just a quick note on what these are. So we measured lexical diversity, the rate at which respondents used unique words in their answer. We measured, and then sort of like two measures of interestingness or surprise in their answer. One being Shannon entropy and one being KL divergence. One being a slightly more conservative measure than the other here. Okay, so jumping back to the results, so you can see here that there wasn't actually a ton of change in any of these things between the initial response given to a question and then the post-probe response given to a question, and even when you combine them together. And moving to respondent experience, we measure this both behaviorally and in a self-reported way. Behaviorally, we see that a clear indicator of a bad response would be if you exit the survey, right? And indeed, we found that for the elaboration and relevance probing conditions, there was a slight uptick in attrition right after the first question. That's what you're seeing here, but not really much after the fact. So once you're okay with being probed in a survey, it seems like you stuck around for the rest of the survey. And interestingly, we didn't actually see this at all for the confirmation probing condition. Or at least if we did, it was very, very noisy. We found a small negative effect of probing, like I said, on self-reported experiences. So the respondents who did stick around in the survey, I should say, the results here are standardized on a 0 to 1. So the outcomes are normalized to 0 to 1. So, and the original scales were 5-point Likert scale questions. And so you can see here that in the elaboration, this is treatment 1, there were slight, downticks in evaluations of frustration and satisfaction and ease. We actually asked some like open-ended questions about like why, if they reported frustration, like why they found it frustrating. Some of them, were just like, it's kind of interesting. Some of them were just like, had to do with just like AI as a whole, like just interacting with the AI versus a human, felt awkward, it felt not natural. Some of them, interestingly, had to do with the latency of the probes that were generated. So talk more about this in Q&A. I'm going to pause here and just take a look at the questions. If there are any clarifying questions here. Categories predetermined. Yep, so the categories are taken directly from the code books and the reference questions that I mentioned here, right? So the reference questions here are determine the code books. And maybe I'll just hold on questions until the end, which we're very, very close to. So where did my mouse go?
It's up on the screen.
Oh, thanks. So let me just jump ahead. Okay, so to sort of summarize what we've seen here, if you had to take away one message, generative AI, it seems, without a whole lot of work from us, can provide some useful survey data in terms of, accurate codes and more specific and relevant responses, right? These two categories being the aspects of response quality that did increase, but too much likely creates a lower quality experience. So the too much part we can't actually attribute directly to this survey. You might imagine the way to actually determine this would be if you varied the number of questions in which we administered probes. But that this is actually maybe more of a hypothesis than a conclusion. But certainly some learnings here about respondent experience having to do with probing. And actually, this is actually quite consistent with previous literature on human-administered conversational interviewing, interestingly enough. Of course, our version being scaled up and deployed over the course of 2 days, as opposed to maybe weeks or months, as would be the case with conversational interviews. Okay, so the road ahead for NorkBot here, that's what we named our text bot. We got really attached to him after, during the course of the survey. So we've established a floor, right? So again, we did all this with like almost no fine tuning, almost no prompting, besides just, giving the names of the categories for the open-ended responses to our text bot here. And so you might be interested to know, like, what does the ceiling then look like once we actually do, all this work? You might have noticed that the news source question actually had the lowest classification accuracy out of all of our experiments, and that we think has a lot to do with the usage of proper nouns. So CNN was actually surprisingly misclassified quite a lot by our text bot, and maybe the folks who worked on the model have a different CNN in mind, convolutional neural network, and not, the CNN news outlet. But some examples of things where fine-tuning and prompting can definitely help, right? And I didn't talk too much about heterogeneous treatment effects. I have some results in the appendix for folks who are curious. But we found that for mobile survey respondents, like among mobile survey respondents, is where we saw all of these bad things. If you look at just the desktop respondents, we weren't able to actually distinguish a lot of negative effects, either in terms of attrition or self-reported rates of bad experience. And if we look at some of the earlier literature, there's some results suggesting that topical interest in the question matters. If you're interested in sharing thoughts about the news, you're maybe more likely to comply with a probe on that than if not, which of course raises some concerns as well about selection bias in the responses. And finally, just to again motivate why you might be interested in this at all, right? So you could think about use cases for this that might involve, for example, personalizing job satisfaction questions based on not just sector, but their very, very specific occupation of each respondent. You might imagine dynamically generating issue position questions for emerging political issues that you're not aware of and you haven't programmed into your survey ahead of time. And also you might imagine things that are asked currently in a very closed-ended, perhaps artificial way, you could ask in a more open-ended way with the benefit of getting real-time confirmation from the respondent. Okay, so stay tuned. These are all things that we're working on at the moment. I'll just kind of briefly shout out that this is part of a growing generative AI agenda at NORC, which includes some work on the integration of AI into tutoring and in the education space, and many other use cases of AI for survey research. And the write-up for this project is public right now. That we published a little research brief. The full paper is currently under review, but I'm happy to share more about that. And of course, we can keep the conversation going, and be sure to check out this and other work of mine on my website. And with that, I'll open it up for questions.
I think there are a bunch in the chat, so you may start there, and then we can have people, or if anyone just wants to unmute and ask their question out loud, you can do that too.
Yeah, that sounds good. So we have a question in person from George in the room.
Yeah, so when you talk about the RA coding comparison, I assume did you have multiple RAs coding? And I'm curious, what was the RA disagreement like? Were RAs generally all agreement on their classification, or was there actually a range of ratings amongst the RAs?
Yeah, so it's a good question. Let me just return to that process slide there. Wherever that is. I think here, yeah. So there was sort of like a natural burn-in period with the RAs. One, purpose of which was to actually discover the quality criterion, but another was also to check the codability of initial responses to these questions. And so that was sort of a helpful calibration period, right, where we resolved disagreements about the substance of particular, not just quality, but also like the classes too. And admittedly, there were some questions for which the code book may have been the culprit for some of the low classification accuracy more than perhaps the text bot. I mean, you might even see here, right, for this question, most important issue, like I think I mentioned like cost of living and wages, those are pretty semantically similar topics, right? And so admittedly we did see some residual source of like confusion from the large language model, both confusion from the large language model and slightly lower rates of agreement than maybe were ideal between the RAs. But I think the intercoder reliability rates, even so, were fairly high. So on the whole.
Amanda, do you want to unmute?
Yeah, sure. Hey, thank you so much. This was so interesting. I work in a private industry context where I field a bunch of surveys, and so I think a lot about the impacts of generative AI on the classification of junk open-end responses, and also on the sort of proliferation of bot responses. So I'm curious what your thoughts are in terms of the the example that you gave was sort of like a gibberish keyboard mashing response, but some of the stuff that's more difficult to identify and that I've had trouble identifying even using generative AI has been things that are like sort of semantically relevant, but not actually answering the question. So I'm curious if you had any sort of experience with that, or how the platform you were using accounted for that.
Yeah, so the question of detecting bot responses, I think, is an interesting one, and something that we're starting to do some work on. Some work that we've already done is sort of like the reverse of this question, which is we actually let both human and large language models respond to a fixed survey. And we sort of like backed out characteristics of bot responses as compared to humans. One of the things we found from this work is like basically bot responses, it's actually the opposite. Bot responses are basically like too good. They're like usually like too long. They're too like it's kind of implausible that someone would, if you look at the timing, right? Like it's implausible that they would give this response in like 5 seconds, before moving on to the next one. You might imagine that for the few respondents who gave like the most informative, most relevant response to each question, I would actually be more likely to. I would actually more suspect that those respondents are the bots rather than the junk, like the high rates of junk, responses. So, anyways, just a preview of some results that we found. Maybe I'll alternate between online.
Yeah, there are bunches that's still sitting in the chat. So maybe since no one's raising their hand or unmuting, maybe just jump to the next one in the chat. If you can see them?
Sure. So I'll go to the chat, and then I'll go to the room here.
Oh, sorry, I forgot about the room. I
Yeah.
can't see them.
Still got a couple of, let's see.
There's one about the categories being predetermined. I think it's the earliest that's unanswered.
Oh yeah, so I think I responded to that. So the categories were from the code books from those reference surveys. So let me move on to the next question. And it says provocative question, which is promising. What is the relative value of standardized survey questions and text responses taken to the extreme? A standard open-ended question like how do you think the country is doing, and let the respondent talk, not write their response, and then have follow-ups in the vein of what I think you're saying is, do I have that right? Yeah, I mean, so like what I think you're saying is, and then do I have that right? That's basically what the confirmation probing is. I think there's something in this question about like letting the respondent talk rather than not write. And actually many of these vendors, Inca included, without turning this too much into a sales pitch, actually offer exactly that. So instead of writing, you can actually like do the equivalent of sending a voice memo for each question. And interestingly, you can actually switch between modes. So if you feel that a certain question maybe is more like talkable, you can do so. And I think that raises the possibility of all sorts of interesting, experiment follow-ups to what we've done here. So maybe I'll switch to the room now. So yeah, do you want to go?
Sounds good. In your experience working with Inca, and you mentioned that there's other vendors in this space, from like a cost and sort of scalability standpoint, what would you say, just total prediction on not holding you to account here, but like the impact on both academic research in terms of like the need for multiple RAs, like the same sort of quantity over these projects, or in the industry, like those more like classifying based roles as well? Like, do you see it working with them or like limiting the need for more human-based work?
Yeah, I think I have two thoughts there. So one is the added cost of all of these large language model capabilities to, what non-probability panel providers already do is actually very low. Like, as you all probably know, or maybe don't know, LMs are very cheap to work with currently. And so, in fact, for many of these vendors, like the testing of these questions, the testing of the probes, and oftentimes the design of the prompts and the fine tuning, you can actually do for completely for free, or at a very, very nominal cost. So that isn't really where a source of costs are. Where costs might come in is in piloting these surveys. And you can imagine like taking what we've done here and using that data to actually then fine tune all of the text bot for each of the questions. And so that might be where costs come in. I think there's definitely follow-up work for us to do in thinking about what that process looks like, right? Of like fine-tuning, piloting. Maybe you have multi-round pilots in the case of particularly tricky questions. But those are some of my initial thoughts about costs. let's see, I'll move to the chat again for another question. So, question from Amanda, do the mean interview lengths vary across experimental groups? Ah, that's a great question. So they do actually, they do. I don't know if I have that in the appendix here. I don't think I have that in the appendix, but the elaboration relevance probing treatment group actually had on average, like I think 3 or 4 minutes longer of an interview, which is substantial. So yeah, the answer is definitely yes there. Okay, so another question from the room. I think you had your hand first.
Thank you for a very interesting talk. I work a lot in survey design of like plain old vanilla surveys. And when I think about survey design, I think about like cognitive testing and pre-testing as one of my best tools to get questions to be good. And then when I'm looking at this AI, it makes me think a lot about prompt stability. And what process did you guys take to get your AI prompts? Like, was there any sort of testing that could be done if I were to go into the field with an AI text bot? How would I get kind of respondent feedback in the development process in the survey like that?
Right. No, it's a super interesting question. So the answer is, I think this sort of work could tremendously benefit from cognitive interviewing, right? I mean, if you think about the literature and conversational interviewing, one of the pieces of this is one of the findings, right, is like you have to have very high quality interviewers who, like, you know, although they're not following a script, like you understand the parameters that they, you know, that they're operating with. And part of that comes from cognitive interviewing, right? And actually observing, you know, how these interviews go. And so yeah, I mean, I haven't thought, you know, more specifically about what cognitive interviews could look like for this, but I think they would benefit tremendously. And then there's the other part of this, which is that, you know, you could use AI for cognitive interviewing itself too, and that raises a whole other set of research questions. But that's something that we're thinking about as well. But yeah, I think that's like a really important line of work that we should do. Yeah. Another question from the chat. So I'm just moving down the list here. So aren't LLMs an overkill for these treatments? Wouldn't some syntactic or semantic rule-based algorithm work? That's a good question. So you might imagine actually for these like factual questions, you know, yes, like, you know, just like straight, you know, like even just like regular expressions to detect things like CNN or MSNBC or those things might be helpful. The problem though is that with a lot of these questions, prime the respondent on the exact like level of granularity that you want from them. So we got responses that were CNN, but we also got responses that were like, I don't like mainstream news. I subscribe to people I trust. And so what do you do with that, right? So there you need at minimum, I think you need something that understands, you know, like semantics, right? So whether it's a large language model like we've done here, I believe that our vendor built their text bot probing on GPT, I think GPT-3. You know, whether it's that or some lighter embedding model, I think that, you know, you would want to have something like that in the mix. But of course, it depends from question to question. And there may be questions where you're okay with, you know, just like regular expressions, which is baked into Qualtrics and a lot of these survey platforms already. So it's a good point. Yeah. Yeah.
Can you help me understand the text complexity results? It was a little surprising to me in part because you know, naively I'm thinking, well, with treatment conditions, you're like eliciting much more elaborate responses from your respondents. And so I would expect that there's just more information there. And so I was a little surprised, and maybe I'm not understanding how that's measured, what's on this exactly.
Yeah, so let me just jump to the slide there about the measures. So this part of this might explain, you know, might have to do with the limitations of these measures themselves. So lexical diversity being like the number of like new unique words that appear in an answer, you know, after a probe. Shannon entropy being the rate of surprise in respondent word distribution. So, you know, the comparison here is the distribution of words across the sample, right? And so I guess the inference to make here is that respondents don't use new unique words in their answer. They're not like suddenly switching to like Shakespearean prose after, after we give them a probe. And they're not necessarily using new words that really like uniquely flag them among their peers in the sample. Having said that, they do provide, they use, maybe the way to think about this is like they, noting that the specificity and the explanatory details did increase when we asked the RAs to look at this, is that, they weren't using a lot of new, novel language or, like words, but they were able to draw on other concepts, maybe not surprising concepts in themselves, but other concepts to explain their answer. I mean, if we look at this example here, right, like, so like poverty is really real. Poverty is not a word, like a surprising word. It surely was used by many other respondents, maybe even in their first answer, but, just providing some of this, some context, drawing on other, relatively lightweight concepts, if you will. I think that's what we saw.
And so if I can try and repeat so I understand, so
yeah,
like all the respondents in the treatment condition, their answers after probing are compared to other respondents in the treatment condition to see if like their individual responses are unique, and then that's compared against something against the control group.
Yeah. So I forget exactly what the distribution was that we looked at. I think we did it a couple of different ways. I think we looked at the distribution of words in the pre-probe respondents, and also among control group respondents.
Mm-hmm.
And neither of those really changed very much. Yeah. Yeah. Okay.
Sake of time. Question, if there's one.
Yeah, that sounds good. Let's see, payment or motivation of the respondents. So I don't have a ton of details about that, but respondents were paid. Metrics like F-score, not in this work, but some of our follow-on work, and I think the full paper looks at F-score. Response latency, comment about response latency here. LLMs will be much quicker at providing a follow-up. I'm doing kind of a speed round here. Yes, but there were instances where the LLM had some noticeable response latencies in generating their probe. I think that's it from the chat. Any other questions from the room, or anyone want to unmute and ask one last question? Okay, I guess seeing none, I guess we can end there.
Thank you so much for an interesting talk.
Great. Thank you all.